Okay, for this problem, what you want to do is draw the graph, because you have a line and you are asked to optimize the distance between the line and the origin. Okay, so let's graph the line 4x plus 7. You know you need to be able to see the y-intercept. 7. And here's our y-intercept. The slope is positive 4, so I can go up 4 over 1, or what I'm going to do is go down 4 and back 1. So down 4, back 1, that's good enough. And then you can get a general idea of what the line looks like. Now it's just a sketch, so you can figure out what they're really asking for. Now they're asking for the line that's closest, or I'm sorry, the point on that line that's closest to the origin. So why don't we start with kind of focusing in on the origin, and then go, okay, I want the point on the line that's closest to it. Let me take a real pale color. So maybe it's like right here, right? Or maybe it's right here. Maybe it's right here. The point on this line, on the black line, that's closest to the red point. So how do you know that length of that line, right? Well, the length of any of these lines is just given by the, try to finish my sentence, okay, is just given by the distance formula. The distance formula is the square root of y minus y, quantity squared, plus x minus x, quantity squared. Or you probably are thinking of them in the opposite order, which is just as normal. Okay. Now, let's keep in mind what these points are. This is the origin. And you're probably thinking, okay, well, what is this point over here, right? Because we don't know. Well, the point over here is you don't know what the x value is, and you don't know what the y value is, but you do know that y is 4x plus 7, right? Okay, so let's go quantity x minus x, quantity squared, plus y minus y, quantity squared. Okay, now let me finish this square root. Okay, so this is just going to be what? The square root of x squared plus, just square this binomial. The plus 0 doesn't really matter. It looks like a times, but it's a plus. 16x squared plus 28x plus 28x. So what is it? 56x plus 49. This looks terrible. Plus 49. Okay, so let's go to the next line. Well, after we combine these two, right? So now we have a distance is the square root of 17x squared plus 56x plus 49. Alright, one thing you want to keep in mind is that with things, a square root here, anything under a square root, think about this, you know, what's bigger? This or this? Okay, well this is 10, this is 2, right? The bigger the stuff underneath, the bigger the square root's going to be. So if we want to, same thing, it's, you know, similarly with smaller. The smaller this number is, the smaller this number, the square root's going to be. So if we want the closest to the origin, we're trying to minimize the distance. So the reason I'm saying that is because I don't necessarily want to just minimize that distance that I had there. I'm going to call this d sub 1. It's the stuff that was under the square root. The 17x squared plus 56x plus 49, the stuff that was under the square root. If I minimize this, then I minimize everything. All right, well, how do you minimize something? Take its derivative. 34x plus 56. Take the derivative, set it equal to 0, and divide. Okay, so what is this? 28 over 17. Okay. So now you just have to verify that that's a minimum. And we'll call this D1 prime. Remind me in class, we can go over, you'd probably rather ask questions on this thing. Why is that true? Like, why do they have the same minimum? Because I really did alter this function, right? They really do have the same minimum because one of the functions, say, looks like this, but another one of the functions maybe looks like this. And do you see how even though the functions are different, because one would be square rooted and one wouldn't, they would have the same minimum value. Okay, so going back to this, all you have to do is ensure that this is negative and this is positive. Well, let's pick something over here like, say, a 1. And then let's pick something over here like, say, a 2. If I plug a 1 into this, okay, so you may have noticed that when I went to, let me grab an eraser. I guess I can't. I'll grab a white. When I went to do my sign chart, I realized they're always positive, which made me fix the mistake some of you guys were probably yelling about at home. The mistake was, yes, swinging the 56 over makes it negative. So this is a negative. So I can put in, still the 2 is fine, that's going to give me a positive. If I put in negative 2, I'm going to get negative 68 plus 56, which is negative. So this does, in fact, verify that the function is decreasing and then increasing, so we found our minimum. So our minimum is at x equals this. Why didn't that circle? X equals this. So negative 28/17. And I will leave it up to you to get the y value because I don't want to make this recording too long. Okay, sorry, the whole iPad froze when I went to go back to the first slide to show you the original equation, but that's how you have to get your y value, right? So I believe it was 4x plus 7. That's what you have to do. Plug, because I don't have a pen, plug this x value into the y equals 4x plus 7. Plug that into there, get your y, and you're done.